Welcome back. Let's do example 4. At the end of each month, Sean deposits 5,000 into a savings account. Sean wishes to have 4 million rands in his account at the end of the investment. Interest is calculated at 13% per annum, compounded monthly. How many years will it take him to have 4 million in his account? Again, this is savings. So we're going to use a future value annuity. We have our future value annuity formula, which says F is equal to X and then 1 plus I to the power N minus 1 over I. And then what we have here, we have the future value, which is 4 million. Right? We have X, which is the monthly installment of 5,000 rands. And then we have our interest rate, which is 13% per annum compounded monthly. So is 0.13. Okay, how do we get the decimal? Just say 13 divided by 100. Then now divided by 12. Okay, if you want to use it as a percent, you can say 13% divided by 12. So we're dividing by 12 because it's compounded monthly. So now this becomes the monthly rate. And then what are we looking for? We're looking for N. Okay, right, which is the number of payments. But it says how many years. From the number of payments, then we're going to get the number of years. Okay, right, let's substitute what we have. We have 4 million is equal to the 5,000, which is the X, and then 1 plus I, which is 0.13 over 12 to the power N, that's what we're looking for, minus 1, all this over 0.13 over 12. So what we do here, we want to find N. We may do things different here. Some people can say 5,000 divided by 0.13 divided by 12 first, but I prefer this. I will multiply both sides by this. Okay, let's multiply 4 million by 0.13 over 12. Do that, we must get what? We must get 130,000 over 3. Okay, and then is equal to 5,000. Right, leave it as a fraction like this. Okay, because we don't want to round off during calculation, so it's better we leave it as a fraction. And then 1 plus 0.13 over 12 to the power N minus 1 like this. Okay, right, and then after that we divide both sides of the equation by 5,000. If you say 130,000 divided by 3, and then this divided by 5,000, you must get what? You must get 26 over 3 is equal to, and then this side we're just left with this. So it's going to be 1 plus 0.13 over 12 to the power N minus 1. Okay, make sure you're doing this in your calculator and you're getting these values. Right, and then what we do next, we add 1 on both sides of the equation, so that we have 26 over 3 plus 1, you get 29 over 3 is equal to, then this, you can put this in the calculator, 1 plus 0.13 over 12, and then we must get 1,213 over 1,200, right, to the power N like that. Okay, now we can change this from exponential to logarithmic form. Remember, when you're changing from exponential to logarithmic form, the exponent is the subject. So N is equal to, then log. This is the base. Okay, this is a power. If you check this, this is the base, this is the exponent. So now our base becomes this, which is 1,213 over 1,200. And then our number, the argument, you put it here, 29 over 3 like that. Okay, so there is this function in your calculator. You can use this function. Just put this thing in this function as it is, and then you must get N is equal to 210,5492469. Right, let's say you don't have this in your calculator. What can you do? You can say N is equal to log, then log this number, the argument becomes your numerator, log 29 over 3 like this, then divided by, then log this base being your denominator there, 1213 over 1200. You're going to get the same answer, 210,5492469. This is a number of payments, and since the payments are done monthly, and then how do we get the number of years? We divide by 12, 210,5492469 divided by 12. This will give us the number of years, which is roughly 17,54577088, right, which is roughly 18 years, which is roughly 18 years.